So we are on the Math 9 Unit 8 test review. Of course, we will start on this. If there's any issues, please email me if you have any questions. Okay? All right, so we'll start here with these um, terms. You need to add them. In order to add, you need to make sure that they all have the same radical. You can't just combine those terms like multiplying. Like in this case, we can combine unlike radicals, but with adding and subtracting, you cannot. That's almost that's almost true for almost all the situations when you have um, adding and subtracting fractions. You can't add without like common denominators. And here, like multiplication, you can't. So adding and subtracting is always harder. All right, so we're going to try to simplify this. This can't be simplified. It doesn't have any perfect squares, but 24 does. 24 has the square root of 4 times the square root of 6. Okay. Of course, that 3 is on the outside. The square root of 4 is 2. Whatever comes outside multiplies by what's already outside. So 3 times 2 becomes 6. So this 11 square root of 6 stays the same. Plus, this now becomes 6 square root of 6. Okay. 54, does 54 have any perfect squares? I would think 9. Okay. So 9 and 6. 54 breaks down into the square root of 9 times the square root of 6. Of course, that subtraction sign stays there. Square root of 9 we know is 3. So this now becomes 3 square root of 6. Now that they all have the same number inside the square root, we can combine the outside term. So it's going to be 11 plus 6 minus 3. Okay? So 11 plus 6 minus 3 becomes 14. So this now becomes 14, and then the square root of 6 just stays the same. We do not change that. When we're combining the terms, we're adding and subtracting, you don't change that. You just leave that alone. Okay, so this is our answer for number 1. All right, so for number 2, we could multiply these huge numbers together, but they're so big, I wouldn't. Okay, I would try to see if there's a perfect square there. Yes, 9 and 5. Okay, and of course 9 becomes 3 on the outside. So this now, a prettier, easier problem here is 3 times the square root of 5. Okay, so 45 becomes 3 times the square root of 5. Here, of course, 3 is on the outside still. What comes out there? This is the square root of 25 times the square root of 3. Okay, I broke that down in square root of 25. Why? Because 25 is a perfect square. This becomes now 5 on the outside. 3 times 5 multiplied by each other becomes 15. So this is still multiplied. 15 and then the square root of 3. Okay. So now that we have these two problems, much, much easier to multiply. So when you're here, you could multiply these numbers and get a huge, huge number, but I wouldn't do that. I'd break it down first like this, and now you can multiply them. Unlike this problem, here you can combine unlike situations when you're multiplying only and dividing, of course. Okay, dividing is a totally different situation as well, but here you can combine them even though these two don't match. Basically, what you're going to do, the outside number should multiply. So you're going to multiply 3 times 15. This becomes 45. I multiply 3 times 15, and then you multiply these two inside numbers. 5 times 3 is 15. And this is your answer. We cannot simplify this because it doesn't have any perfect squares in there. And then the outside number just became 45. Okay. Situation here, this is a cubed root, but it's the same as number 1. You cannot combine them unless they have like terms, okay, on the inside of the radical. Let's see. All right, so 54, but remember, this is 3, okay? So your root is 3. So you need 3 of the same number in order for it to come out one time. These are square roots. This one is a cube root. So 54 we know that becomes 9 times 6. Is that correct? 9 times 6. Good. And then, of course, 6 is 2 times 3, and 9 is 3 times 3. Okay. So do we have 3? Yes, we have 3 3s here. 1, 2, 3. 3 3s come out one time. So this negative stays. So negative 3 is on the outside now. I took out the 3s. The cube root of 2 is left inside. There's nothing we can do. There's only 1, 2 left over inside. So we have to leave it there. And of course, this is a cube root. It's hard to see here. So that's a 3 for a cube root. Okay. So, and of course the negative there. So the what number came out became negative. Okay. So let's try here. Of course, there's a 5 there, but let's break 16. 16 is 4 times 4. And of course that is, oh, and I haven't done the x to the 7th yet, but I'll do that in a minute. And of course that's 2 and 2, and this is 2 and 2. This now, of course, the 5, there's 3 2s in here. Okay, 3 2s comes out one time, and the 5 is already there. 5 is there, 3 2s came out. I mean, 1 2 came out, excuse me. 5 times 2 is 10. Okay, and of course, the cube root of 2 has to stay inside. Okay, now let's do the x to the 7th. So if you have x to the 7th, of course, there are 7 x's, 3 of the same come out one time, or this is how we would have done it in our notes. Okay, I will take, oh, sorry, not a 4, a 3, cube root, and divide it by whatever the exponent is. How many times is 3 going to 7? 2 times. 2 times 3 is 6, minus 1. So 7 minus 6 is 1. This is how many are inside, and this is how many come out. 2 come out, and 1 stays in. Okay? So 2, x squared comes out, x squared comes out, and 1x stays inside. So this now becomes negative 3x squared, and then the cube root of 2x, plus 10x squared, and the cube root of 2x. Can we combine them? Yes, they're like term, and then the radicals are like terms as well. So negative 3x squared and positive 10x squared become positive 7x squared, and then the cube root of 2x just stays the same there. Okay, so that's your answer there. All right, so next, I just want you to simplify here. Let's go ahead and break that down. Square root of 9 and the square root of 7. Okay, 14, because this is even, this is just 2, your square root is 2, I would just divide 14 by 2, okay, and get x to the 7th. From, as you see, this x to the 7th is on the outside of the square root. Of course, 9 becomes 3 on the outside. Now for this one, because it's a square root, I would subtract 1 from it, and of course divide that by 2, and then put 1 by itself. Okay, and that 12 divided by 2 becomes y to the 6th. So I'm going to put all the outside numbers together, or terms together, 3x to the 7th, y to the 6th, and then whatever's inside, 7 and y, go together. That is your answer there. And it takes a lot of practice to do that. Okay, I don't expect that to come easily, but you do need to practice that. Okay, simplify each expression. Assume that the variables represent any real numbers. Pay attention to absolute value. Absolute value is important. Of course, do we have the absolute values here? We will see. All right, so of course, divide this by 2. Okay, this becomes m to the 8th power. Okay, no absolute value there. Why no absolute value? Because this is an even number, and then whatever answer comes out becomes m to the 8th. That's even. So you know that that's always going to be positive either way. Okay, but in this case, when we divide this by 2, this becomes n cubed. This is an odd exponent. When you have an odd exponent and an even root here, this has to have an absolute value over it. Okay, odd exponent, even root has to have an absolute value, and that's going to be your hint for your test. So please make sure that if it has an odd root exponent for your answer, put that absolute value there. Okay. Here, write this in simplified form. Of course, this is cubed. So let's start by, I would divide 56 by 2. I'll start by dividing it by 2. All right, so this becomes 2 and 28. Okay, of course, 28, if you divide that by 7, you get 4 and 7. Okay, and this is 2 and 2. Okay, and of course, that's the cube. So 1, 2, 3 2s come out one time. Okay. 3 2s come out one time with 12, m to the 12th. Of course, you're dividing it by 3 for your letters or variables. Divide that by 3, and of course, 12 divided by 3 is 4. Okay, so we don't even really have to go here. We'll just divide this by 3, and that becomes m to the 4th on the outside. Okay, this now, if we divided it by 3, n to the 7th, and we're dividing that by 3, how many times is 3 going to 7? 2. We've already kind of did this before. That becomes 6. 1 is the remainder. This is what's left inside. This one comes out. Okay. So 2 came out. 2 n's are out. N squared. And then what's left over on the inside looks like the cube root of n, just one n. One leftover n. And don't forget this 7. This is n. And this is 7. So what's left over on the inside is 7 and then 1 n. Okay, because it says 1 n is left over inside. So this is your answer for number 6. All right, moving right along. Here for number 7, you are going to distribute. Okay, so when you distribute, you're multiplying the numbers on the inside of the square root, and the outside numbers have to be multiplied. In this case, there's only one outside number, which is 8. This becomes 40. Here, again, no, and this is like a -1, so -1 times 8 is 8. And then the two numbers on the inside multiply by each other, 5 and 6. Remember that the square root of 30 does not have any perfect squares in it. Same thing as the square root of 10 does not have any square roots in it. So you can leave this alone, but this one does have a perfect square. It's like 4. So this one breaks down into square root of 4 and square root of 10, and we know square root of 4 is 2. Okay, so our answer, I'll put a little line here. Our answer here, 2 came outside, but 8 was already out there. 2 times 8 is 16. So this is 16, and then the square root of 10 is left over inside, minus 8 in the square root of 30. Why is this your answer? Okay, this is your answer because this 10 and this 30 cannot go together. Okay, one has a 10 and one has a 30. It's kind of small. Let me put it up here. 16 square root of 10 minus 8 square root of 30 can't combine. Okay, but they have to be separate. Do not try to put them together when you're subtracting and they're unlike in the radical part. So this is your answer. Okay, let's go here. For this G69, basically they want you to replace X with 69. So you see how here X is 69 and this is the cube root. Put that in your calculator. How do you do that? Okay, turn off the light. So basically you're putting in the cube root of 69 minus 5 in your calculator. So push 3. So all I pushed is the number 3. And then second, and then that caret button here, that's cube root. I push 3 first, and then I push second caret. Okay, and that means cube root of 69. I'm going to put in parentheses 69 minus 5 in parentheses. Okay, that's how I put this into my calculator, and my answer is 4. So that is how you get that answer. Okay, same thing here. They want negative 22 in there. So this one is the cube root. In place of X, we're going to put negative 22 minus 5. Okay, and put that in our calculator. Remember, push 3 first, second, and this is the little up button. Okay, and then it's called a caret, and then push parentheses negative 22 minus 5. Put that in that parentheses, and you get negative 3. Okay, so that one is not difficult. Just throw that in your calculator. All right. All right. So now for this one, solve where a is a real number, and this is a cube root. Okay. For this one, all you're going to do to get a by itself is cube it. If it's a cube root and you're trying to get rid of it, then cube it. This becomes a equals 4 raised to the 3rd power. So how you do that? 4, And then this little caret button is raised to third power, and push enter, you get 64. Okay, so your answer there is A equals 64. Okay, now for this problem here, may seem very difficult, but remember your exponent rules. When you're having, you have to multiply first side to side. So here, up here, you just add the exponents. Although they're fractions, just put them in your calculator, add these. Once you get your answer here, you're going to subtract that. So what do I mean? Okay, so the bottom stays the same. Okay, x to the 5 over 4. But up here, what you're going to do is you're going to take -2, and I'm going to use this AB button here. Okay, divided by 3. I'm putting it in parentheses. Plus, because you're adding these two, okay, 8 divided by 3, like that. Okay, push enter, get an answer. My answer is 2. So this now becomes x squared. All right. So now what you do with these two is you take x2 and subtract 5 over 4. Okay. So now we're going to say 2 minus parentheses 5 divided by 4. And of course, I'm going to use this little button here, which is like when your answer will become a fraction, which I want if it just in case it does. Okay, so 3 over 4 is my answer. So this now becomes x to the 3 over 4. Okay, and in this case, they may want your answer as a radical. And this is exponential. They may want your answer as a radical. So make it 4. Remember, the denominator is the root, x cubed. Okay, so that's what it becomes. These two are the same exact thing. Okay, this and this. They may want your answer as a radical. This one is radical form, and this is exponential. I can't spell it. Exponential form. And this one's radical form. Okay. All right. So simplify, right, without parentheses. In this case, these two numbers, when you're raising a power to a power, you multiply. So I'm going to take 3, okay, and multiply it by 6 divided by 36. Okay. So I want my answer as a fraction, so I'm using this here. Okay. And I'm going to push enter. My answer is 1/2. So here, once I multiply them, so basically what I did, I multiplied 3 times 6 over 36, and I got m to the 1/2. And of course, I'll try to write my answer as a radical, and this will be the square root of m. Okay, these two are the same. This is my radical form. I'm not even going to try to spell exponential. This is my exponential form. Okay, radical form, exponential form. All right, so in this one, I may need a separate piece of paper and graph. All right, so suppose that an object is dropped from a height of each meters, hits the ground with a velocity of v meters. Okay, so then it says v equals the square root of 20.1 h. Okay, I do want to write that down. If an object hits the ground with a velocity of 22.4 meters per second. So basically what they're saying here is that velocity. Okay, this is my formula that they give you. They're not giving you the height, they're giving you the velocity. And they said the velocity is 22.4. Okay, everything else stays the same. And then it says from what height. So now they're asking you what is the height. Okay, so in order to get rid of the square root, because everything's under the square root, let's first get rid of the square root because we need to try to find what the height is by squaring it. Okay, so what does this do? You get rid of the square root. This now becomes 20.1 h, and we have to square 22.4, square it, and for that we get 501.76. And now to get height by itself, which is what we need, we'll just divide by 20.1. Okay, divided by 20.1, And our answer there is 24.9, round to the nearest 10th. But as you see, this is a 9, this is the 10th, this is a 6. That makes that go up. So in this case, this is a good one, because if it's a 9 and it has to go up, you have to make that 5. So this is actually going to be your height is going to be equal to 25.0, okay, or 25, okay, because this 9, the 6 made the 9 go up, the 9 goes up, which makes that 25.0 now, okay? So that's your answer for number 12. And the height is in meters, 25.0 meters. All right, so let's look at number 13 now. So for number 13, it says multiply and simplify. Of course, for that one, you are going to square it. So if you have, this is for number 13, and of course, this one was number 12. I'm going to model this so that you can do this for your test. Okay, W plus 3 square root of 3 squared. Okay, and we're squaring it. So if you square it, basically you're multiplying it by itself. All right, so now I'm going to multiply this times this. If you multiply the square root of W times the square root by itself, both of those are the square root of W and square root of W. It just becomes W on the outside. Okay, and then let's multiply this times this. Of course, the outside number stays the same, and whatever's inside, 3W, multiplies by each other, 3W. Now we're going to multiply here. Whatever's on the outside stays the same. Inside is 3W, because the outside doesn't have the outside number. And then if I here, 3 times 3, of course, is 9. Okay. And then square root of 3 and the square root of 3 is just 3 on the outside. Okay, so I'm multiplying 9. 3 times 3 is 9. That's why I have 9. And then square root of 3 and square root of 3 came 3 on the outside. So I have to multiply it by whatever's outside. So now, if I combine my terms, this becomes W plus 3 plus 3 is 6. And then the square root of 3W. Okay, and then 9 times 3 becomes what? 27. Right? So that is your answer there. You cannot combine unlike terms when adding and subtracting. So here, unlike, and these two are unlike, and those two are unlike. So you just leave it like this for your number 13, the first part of number 13. The second part, though, of number 13 is the square root of W minus the square root of 3, and then the square root of W plus the square root of 3. Okay, that looks like a difference of squares. All right, so we'll do that one. So now you're going to multiply the square root of W times square root of W. We know that if you're multiplying two of the same square roots, it just becomes whatever's inside, outside, that becomes W. And then the square root of W times the square root of 3, that now becomes the square root of 3W. Okay, and then here the negative square root of 3 times the square root of W becomes negative square root of 3W. And then, of course, the square root of 3, negative square root of 3 times positive square root of 3. When you multiply by the same square root, because this has a negative on the outside, this has a positive, of course, it's going to be negative, but when you multiply the square root of 3 and the square root of 3, it just becomes 3 on the outside. Okay? Looks like these two middle ones cancel out. That's what will happen with the difference of squares. But these two middle cancel out. This becomes now W minus 3. That is your answer. Okay? W minus 3 is your answer for that one. So those are the two problems from number 13. The top one here and then the bottom here. Okay? So we did them both here. All right, so let's look at number 14. Number 14 says solve and simplify. Assume x is a real number. This case is x cubed. We want it just to be x. So the opposite of x cubed is cube root. So we're going to take the cube root of both sides. This now becomes just x. And if you have the cube root of negative 13, okay, if it's negative on this side, it can be the cube root of negative number because cube can have a negative. If it was a square, it would become like an imaginary number, but it's not. So this now, if you have the negative on the inside, go ahead and bring it outside. So this now becomes negative cube root of 13. Okay, that is the answer there for number 14. I'm kind of checking it. Yeah, I think that's fine. All right, so let's look at, but this is a possibility. This is also a possibility. If you put this as your answer, I will still mark it correct. Either one is fine. All right, but this is a possibility because the cube root on the outside means it can be negative inside the cube root. Okay, it can be positive or negative, but if it was a square, it couldn't be negative in here without it being imaginary, which we probably will go through later. Yeah, we have eyes later. All right, so let's look here. If you're multiplying these two, what I would try to do first is break this down. Okay, if there's perfect squares in here, there's a 9 and a 2. Okay, and of course here you just divide it by 2. Okay, so this now becomes 3 on the outside. So this is 3 and then the square root of 2. Okay, let me see, 6 divided by 2 became m cubed. This is on the outside. This does not have a cube root, square root, but then that n has to stay inside. It doesn't have a partner. So all of this here became 3m cubed and then 2n times, okay, you're going to be multiplying this. I can, for this one, of course, the 2 has to stay inside, but m to the 6, I can subtract one from it, put one m by itself, and this one, of course, I can just divide by 2. So this becomes n cubed on the outside. That one I divided by 2 becomes m cubed because 6 by 2 divided by 2, and that becomes m cubed. So what happens here is the n and the m come outside. So this becomes m cubed, n cubed, and then it's multiplied by 2, and that m is still left over inside. Don't forget about that m that's left over. So now all the outside numbers multiply and the inside number multiply. So here it becomes 3. And what do you do when the x, with the exponents here? Because you're multiplying, you add the exponents. That becomes n to the 6th, and this is n cubed. And of course, 2 times 2 is what? 4n m. This n and this m have to go together, okay? And again, you can't take anything out, but you can take this 4 out. But what's the square root of 4? Square root of 4 is 2, okay? So now this 2 multiplies by this 3 on the outside. Your answer, your final answer is 6m to the 6th, n cubed. And of course, n and m have to stay inside because they're single. So that is your answer there. Again, there is multiple ways to do this problem. You did not have to do it like this. You could have put them together and did something else, but this is just how I did it. And I had to make sure that I simplified all the way down to until I got here. There's nothing else that can come out of there. Okay, but you do, while you're doing all this, you do have to remember that you're multiplying these two. Okay. All right, so here I want you to solve, and we've done this before. These problems are a lot, but we will get through it. So I'm going to write this on a separate sheet of paper. Equals the square root of x minus 25. Okay, so with this particular problem, what you're going to do is you are going to square it all. Okay, because what we're trying to do is get rid of the square root, but well, right now we have to just do it on one side. If you take the square root and square it, it becomes x minus 25. Okay, here, of course, if you're squaring it, it becomes 5 minus the square root of x and 5 minus the square root of x. Okay, 5 times 5 is 25. 5 times the square root, negative square root of x, this becomes negative 5 square root of x. Negative 5 square root of x is negative 5 square root of x. And then, of course, 2 negatives become positive. And then if you're multiplying square root of x times square root of x, this is x on the outside. Okay, and of course, this is x minus 25 here. All right, so this now becomes 25, and then negative 10 square root of x, because you have to combine these two like terms. These two are like terms. That becomes negative 10 square root of x, and it's plus x. Didn't change anything over here. Okay, I'm going to get rid of every single thing. Okay, so that we can get the square root by itself. So I'm going to subtract x and subtract 25. Subtract x, subtract 25. This now becomes negative 10 square root of x equals, this now becomes negative 50. Okay. Now we can divide by negative 10 because we want that square root by itself. This becomes the square root of x equals, and negative 50 divided by negative 10, positive 5. And of course we square it because we want to get that exponent, the x by itself. So this now becomes x equals, please don't, so when you square it, don't forget that you have to multiply this, 5 squared, it becomes 25. Okay, so that is your answer there. All right, so for number 17, cube root of negative 64. For that one, of course, you're going to break it down so that you can try to find 3 of the same thing. It can be negative. Negative is fine in here. This is not no solution. Please be wary of putting no solution as an answer. Usually that is not true. But anyways, so I wrote them down here. We're going to solve them. So of course, for this one, you're going to have a negative on the inside. We're going to bring that negative on the outside with your answer, but let's wait for a minute. For this one, of course, it's 8 times 8 is 64. We're going to break that into 4 times 2. And this one is the 4 times 2. And then 4 into 2 times 2. And this one into 2 times 2. Okay, so 1, 2, 3, 3 2s there. 1, 2, 3, and 3 2s there. So how many 2s came out? 1, 2 2s came out. 1, 2. Do not forget that it's negative. When it's negative on the inside, that negative is going to come out. So your answer is going to be negative 4 there. Okay, negative 4 is your answer there. You can honestly just put this in your calculator as well. I'll show you how to do that. Cube root, second, and then the caret button. So this is going to be cube root of negative 64. And then you push enter. Okay, your answer is negative 4. Let's do this one as well. So this one is the negative 4th root. So I put 4, negative 4th root, okay, of 81. And then I'll put enter. I get negative 3. So your answer here is negative 3. Okay, and you should know that because this becomes 9 times 9. And 9 times 9 is 3 times 3. Okay, so of course if it's 4th root, then there's 4 3s here. It comes out 1 time, and there's a negative waiting for it, so it becomes negative 3. That's how you got that. Okay, you can just throw that in calculator if there are no variables. So either one of those is your answer there. Okay, so we did get negative 4 and we got negative 3. You could put those in your calculator. This one you can also put in your calculator, believe it or not. So for this one, you put, let's see if you can, because sometimes it just won't work like that. But let's see, 27, and we're going to raise it to the, 5 over 3. 5 divided by 3 power. Okay, so I put this in my calculator as is, and we're raising it to the 5 over 3 power, push enter, and look at that, you get 243. So this one is a simple problem if you just try to throw it in your calculator to see if you get that answer. And this calculator is so invaluable. Need it. That is 243 there. Okay, perfect. All right, so now that looks 243. Okay, all right, so let's look at number 19 here. it's rationalizing the denominator and simplify. So for this one, you know that this is cube root of 3 on the top, and of course, cube root of 16 on the bottom. Let's simplify this to see if we can, because we know that's 4 times 4, and that's 2 times 2, and that's 2 times 2. Okay. How many come out? There are 3 2's in there, but there's that extra one. So basically, what this looks like when we simplify, 1 2 came out, and then 1 2 is left over inside. 1 2 left out, and 1 2 is left over inside. To rationalize that denominator, how many more 2's? We need to get rid of this. How many more 2's do we need in there? Looks like we already have 1, but we need 2 more in order for it to come out one time. So what I'm going to do is give it 2 more, okay? But if I do that, then I have to do the same thing here, okay? So now that it has 3 2's, 1, 2, and 3, it'll come out one time. So the 2's out here already, but there's now another 2 out there. Let me move that down, okay? So we had 3 2's, we have 1 already there, and now these 3, 1, 2, 3 come out one time, and that becomes 2 times 2. At the top now, though, we have 3 times 2 times 2, because all of those are inside, okay? So 3 times 2 becomes cube root of 12. Cube root of 12. Sorry about that. And of course, nothing can come out there because we have that broken down. There's not 3 of the same thing. But at the bottom, we can make that 2 times 2, which is 4. Okay, and that is my answer there. Now, they keep coming back to this. This is super important, Pythagorean theorem. If you remember, a squared plus b squared equals c squared. For some reason, you guys miss this a lot on your original test, but you shouldn't have, because your this right here with diagonals always your c value. This is a and this is b. Okay, so or it doesn't matter really with the a and b part. Those can be anything. So with the 32, it could be either A or B, it doesn't matter, but C has to be this line here, the diagonal line, okay? So I'm going to make 32A squared, okay? In place of A, I'm going to say 32 squared plus B squared. I don't know what this value is, and that's what I'm looking for, equals, place of C, I'm putting 37. 37 squared. 37 squared. So for your calculator, you're going to put 32 squared, that'll be 1024, plus b squared equals 37 squared, okay, which is 1369. So of course we're going to subtract 1024 from both sides. B squared equals 1369 minus 1024, and I get 345. And to get b by itself, we have to take the square root of each side. Okay, and it says round to the nearest 10. So b is going to be equal to the square root of 345, square root 345, which is in the round to the nearest 10th, which is here. 7 makes that 6, 18.6. Okay, 18.6 is your answer there. All right, good. All right, here for number 21 now, we are going to FOIL it. Negative 5 times 3 becomes negative 15. Negative 5 times 5i. And remember, with I times I, okay, I times I is I squared. That should be equal to negative 1. Don't forget that. Okay, I squared, when you multiply I times I, it gives you negative 1 as an answer. Okay, not in parentheses, but just negative 1. Okay, I times I, which is I squared, is negative 1. And we'll see that here working out. But by negative 5 times 3 became negative 15. Negative 5 times 5i is negative 25i. Okay, negative 3i times 3 is negative 9i, and negative 3 times 5i, negative 3i times 5i is negative 3 times 5, we know is negative 15. Okay, but of course we said I times I, which is I squared, is negative 1. So negative 15 and negative 1 happens there. Okay, so now, of course, negative 15 stays the same. We combine these two. We have negative 25 and negative 9. Negative 25 minus 9. Okay, negative 34i. Negative 34i. And then we have negative 15 and negative 1. That becomes positive 15. Looks like the two 15s, negative 15, positive 15 cancel out. Negative 34i is your answer. Okay, if there was a number like 2 or 7 or whatever, you put that first. So it'd be like 8 minus 34i. But in this case, the I is the only answer. Okay. All right, couple more and then we are done. So here, simplify as much as possible. This looks nasty. I'm not sure what we're doing here. Let me take a look at this. And then this one too. Let me look at this. All right. So I don't know what happened with that editing on that Word document, but it kind of messed up the editing. So here is the actual problem: 3a 48ab squared minus b, and then this. So two different radicals, and you're subtracting here at multiplying here. Okay, same kind of thing we did at the beginning. So here, of course, you're going to be trying to find perfect squares there. I would divide that by 16 actually. Okay, so I would use 16, but you can use 4 if you wanted to, but then you'd have to break something down. 16 and 3 becomes 48. Of course, that's a to the 1 power, so can't really do anything with that, but the b squared, we can divide that by 2. Okay, so this now, of course, the square root of 16 is 4. So this becomes 3. 4 is on the outside. It looks like a is there, and the b2 divided by 2 is just b to the 1 power. Okay, that just becomes b on the outside. But don't forget that a is still inside and that 3 is still inside. So the square root of 3a is still on the inside, right? Of course, that now becomes 12ab, and then 3a is on the inside. This, it looks like you can, for the a, make that a squared, put 1 by itself. This now divides by 2, and that becomes outside. So this becomes minus, that is a on the outside. So this becomes AB, okay? And then on the inside, what's left over is just 3 and a, 3a. Okay? So because these have the same radicals and then they're like terms on the outside, 12ab minus 1ab is 11ab. And then 3a, of course, stays the same there. Okay, so that is your answer for that one. For this one, I would take it and make it 9 and 3. Of course, this is cube root, so all you have to do right there is just divide that by 3. Okay, so that x comes on the outside. This now becomes 3 on the outside. So 3x outside. Cube root of 3 is left over there. This, I know this is 9 and 6, but don't forget this is cube root, so we have to keep going. 2 and 3. Okay, so this becomes 1, 2, 3 on the outside, and you're multiplying it, so 3 on the outside, and then it looks like cube root of 2's left over inside and x squared. Okay, so we're multiplying these two. So all the outside numbers multiply together. This now becomes 9x. Okay, and then the cube root of 3 and then 2 is 6. 3 times 2 is 6, and then x squared has to stay inside. So that's it. Don't try, like really try when you're doing your work to make this look like a cube root as opposed to a exponent or whatever. So 9x is on the outside, cube root of 6x squared is on the inside. Okay, so don't confuse yourself when you're writing that out. Easy to get confused. That's a cube root, not a x cubed. Cube root. All right. Rationalizing the denominator. I'm going to grab a piece of paper for this one. Our last couple, this one, it shouldn't be too hard, but this one, we're rationalizing the denominator. So for that one, it's going to be 2 square root of 7 plus square root of 5. And here it's going to be the square root of 7 minus the square root of 5. Don't forget for your conjugate, because this is what you're going to use here, it's a conjugate, you are going to use for this one. It's going to be the square root of 7 plus the square root of 5. That's the conjugate. Okay. Here. Okay, because we're trying to get rid of the square roots at the bottom. So when you FOIL this, the square root of 7 times the square root of 7 is just 7 on the outside. Okay. Square root of 7 times the square root of 5, of course, is plus the square root of 35. And now I'm doing this one, negative square root of 5 times square root of 7 becomes negative square root of 35. Negative square root of 5 times square root of 5. Remember, it's negative because one's negative, one's positive. Those two together just become 5 on the outside. Square root of 5 times square root of 5 is just 5 on the outside. Okay. So now these cancel out. This is at the bottom of the fraction, don't forget. And then 7 minus 5. Okay, that's what's left over. 7 minus 5 is just 2. All right, so all of this at the bottom became 2. Now let's look here. 2 times the square root of 7. Okay, 2 times square root of 7 times the square root of 7. Of course, those two, the 2 just becomes 2 on the outside, but those 2 become 7 on the outside because square root of 7 and square root of 7 is just 7 on the outside. Right? And of course, that becomes 14. 2 times 7 is 14. Then when you multiply that times that, that becomes 2 square root of 35. Okay, and now I'm multiplying 5 times this, and that becomes plus the square root of 35. And then I multiply that times that. And of course, the square root of 5 and the square root of 5 is just 5 on the outside. Okay, so 14 plus 5, 19. So this becomes 19 plus, if I had to add these two combining like terms, that becomes 2 plus 1, which is 3, and then the square root of 35. Okay? So can't combine any of those, can't really simplify. This is your answer here. Okay? And this can be your answer because there's no radicals at the bottom of a fraction. So that is your answer for number, this one is 24. Okay? That one is number 24. All right, so we did that one. Finally, this one here, not so difficult really, because all you'd have to do, because this is subtracting it, distribute the negative here. Okay, so this becomes 4 minus 5i, and all the negative does is change the sign. That now becomes negative 5, and that becomes plus 4i. And then combine like terms, put the number first. 4 minus 5 is negative 1. Okay, so the number goes first. That's in standard form. And then negative 5i and positive 4. Negative 5 and positive 4 become negative 1i minus I. Okay, so that is your answer for number 25. And this is your Unit 8 test review.